Good afternoon. Thank you for coming. We're going to talk about Narcos, Counterfeiters, and Scammers. Everyone make sure you're in the right presentation you want to hear. Talking about how to visualize illegal markets using passive DNS in partnership with from Farsight, and Stefan is from Cyber Angel. My background right now, I'm the CRO for Farsight Security. We do passive DNS, real-time data analysis. I've been doing privacy and cybersecurity since about 2003, and before then, I have nicknames which I won't quite tie for law enforcement here. And before that, I was one of the original Tor project members from 2003, and then the State Department hired me in 2009 to grow Tor, and also had the side effect of keeping all of us employed with the criminals using Tor heavily. So
Hi, I'm Stefan Kirodi. I'm the CTO of Cyber Angel, a company specialized in large-scale crawling and scanning of the internet for data leak detection.
Okay, so the threat landscape has been fast and growing. This is a snapshot of breaches alone and the size of the breach over the past 11 years. There's actually a huge continuum between this where it gets worse and worse and worse. 2016 continues to be the worst of all. Here's the sheer number of breaches and the sheer size. In fact, they don't even fit all in the same slide because the breaches just get bigger and bigger and bigger and larger and more sensitive. So how do you deal with this mass amount of data? Which is what we're going to talk about. So let's start at the beginning. What do we do? So passive DNS, or just DNS in general, I'm assuming everyone knows what DNS is. Most people think it was a solved problem from 1990s. And no one really cares about DNS anymore, unless you're into domain generation algorithms and botnets. But nearly every transaction starts with the DNS lookup. You got to look up an IP address, you want to find Google, you want to find whatever, you got to look up an IP address. It goes back and forth through DNS. As we just saw with the Mirai botnet attacks, they use DNS quite well to start looking at points, and then you can look up the IP addresses of those and tie to which companies and products were used in that attack. If you can watch the initial first requests, you can start to figure out who did the first request, where the attack came from, and who's been looking up things over time. Traditionally, this has been done through zone file analysis. So you register with one of the registrars or the top level domains. Some of them give out their full zone files. Here's every single host name and domain entry in our zone file. You can get these about every 18 to 24 hours. This is fantastic up until the last 5 or 6 years where the criminals have started doing real-time analysis. We've all seen spear phishing campaigns come and go in less than an hour. Set up the website, register the domain, set up the website, target the corporation, get the 2 or 3 clicks they're looking for, shut the whole thing down, and then get a free domain out of it because they use Fastflux, so they never actually had to register a domain. Domain tasting. This obviously runs into a number of limitations. And this also doesn't include the top-level domains, the country-level top-level domains, which do not give out their zone files. China and Russia being 2 of them, but they're by far not the onlys. So what are we interested in? We're not interested in long-lived domain names. If you registered a domain name a year ago, even 2 months ago, generally you're not going to use it for crime. Everything happens in real time within seconds. So you need to be able to look at everything within real time and in seconds. And of course, then there's all these domain name redirection services, which you register and you hide your domain behind something else, which redirect to something else. This also includes link shorteners, Bitly, and all that, to find places to hide malware, which we all know. So what is passive DNS? Passive DNS is not recording all your DNS queries. It is recording above the resolver. So your local ISP or your company runs your DNS server, all those cache misses. When you go to look up fluffybunny.com and it doesn't exist locally, you have to go to the root server to find out, the .com root server to find out where Fluffy Bunny lives. That's what we catch. We have a network of sensors around the world as Farsight, mostly through handshakes and partnerships, and we can see a vast amount of traffic, which is just the cache miss. So what does this provide? It provides the date, the time, and the source of the sensor for where it came from, so we know what part of the world it came from. It does not provide person identifiable information. We do not have your IP address. We do not have anything related to your local machine that made the query. We also do see crazy things people put in DNS packets. I've seen social security numbers, credit card numbers, host names, street addresses, birth dates, everything you can imagine goes inside a DNS packet. and we strip all that out at Farsight because we don't want to be a lawsuit target for the entire world. I have enough of that at Tor. What does this mean? We have a historical archive from about 2010 of 13 billion domain names and host names. Every change that's happened on the internet we have in a database. We can go back in time and look through what's been going on and what your domain or IP has been used for. All this happens in real time. It's about a couple gigabits a second. And we break it down into separate pairs so you can understand it. Not everyone can handle gigabits of DNS per second. So what is this useful for? Research, associations, auditing your partners, plug in an IP range will tell you every domain that currently points at it or has pointed at it, and vice versa. Plug in domain name will tell you every IP address you point at. This becomes more interesting when you start looking at DNS errors in the next domain. When someone writes a crappy botnet and it starts doing domain DGA lookups before the DGA is actually registered. And then with CyberAngel, we put together this, we've done some research and exposed a bunch of counterfeiters and scammers tied to just looking at passive DNS and looking at network science. Network science is the analysis of complex networks. It's used in biological, social, and computer networks to look at, associations using inference statistics, graph theory, and a number of other math terms that I won't bore you with. To explain how you can look at network science associations, find ties and commonalities between large amounts of entities.
Thank you, Andrew. So I will now present the research we did to identify counterfeiters and resellers of illegal goods in Foresight's passive DNS data stream, and how to put them in a human-readable visualization in order to optimize the takedown efforts. I will first go through the methodology, how we process the data, how we refine it, and how we cluster it and put it in a nice-looking visualization that is human-friendly. And after that, we will go through a use case. First, a quick word about our software architecture. I wanted to mention that we did everything with just this awesome piece of open source software, which is Redis. It's originally it was just a key value store, but you can do much more than that. And instead of going with a heavy Hadoop stack, we just used Redis and did everything with it for multiprocess communication as a custom-made message broker, for load balancing, and for monitoring events and statistics in real time. So it's pretty much a magical Swiss Army knife. So Andrew already explained what is a passive DNS. Here you have a country day example. It's a data stream made of records, more or less JSON records, that look like this. First, we subscribe to Farsight's passive DNS stream, where we see 5,000 of observables per second. The observables are called resource record set, and they look exactly like this. So it's a record with attributes and values, and some are more interesting than the others, especially the RR name, which is the domain name, basically. And also the R data, which is the IP address. So here you have, for example, the two different IP addresses that are bound to the same domain cyberangel.com, but at two different times. So we get a stream in real time of these DNS queries. So what we will do is we subscribe to Farsight's passive DNS, and we filter it first using keywords. So what kind of keywords? Because we are targeting counterfeiters and resellers of illegal goods, we will first look for brand-specific keywords. So sorry, there's one picture missing. But if we are looking for narcotics, I will look for the keyword Viagra for Cialis. If I'm looking for counterfeited goods, I will look for Rolex, Chanel, Dior, all the obvious ones. But if I put myself in the shoes of a buyer, what would I do first? I'll just pop out Google and do these kind of queries. And you can see that there are some marketplaces that sell replica goods, counterfeited goods, but do not advertise clearly the brands because they sell many of them. So it's also very relevant to use to look for generic keywords. Here there would be cheap, replica, handbags, watches. So now I have these two different sets of keywords I'm looking for in the passive DNS stream, the generic keywords and the brand-specific keywords. For every single record that I see through the passive DNS stream, I will do a keyword matching. I will do two kinds of matching. I will first do a perfect matching, which is pretty easy. Here I look for the exact string Cyber Angel in the domain name. And I also do fuzzy matching, also called approximate matching. So I look for variations of the domain name. And this is much trickier because it's a much more time-consuming algorithm, especially because we see 5,000 domain names per second. It means we have only 200 microseconds to do the keyword matching. And to do fuzzy matching with thousands of keywords at this pace is a huge challenge. That's the first challenge we faced, and to overcome it, we found a nice little trick. It's DNS Twist, great open source project. You can find it on GitHub. If you don't know it already, it's you give it a domain name like cyberangel.com, and it computes all the variations that are commonly used by the bad guys to drive traffic to their version of your website. So we pre-compute all the variations using DNS twists, and we look for perfect matches of these variations. So to overcome this first challenge, what we did is change the problem of fuzzy matching into a larger problem of perfect matching, and it works. So we look for all these keywords in the feed, and we managed to filter it down by 99%. So on the use case we will study later, we set aside 50 domain names per second. And it's 50 websites that needs further investigation. So on these 50 websites per second, we launch specific crawlers, homemade crawlers, for an in-depth analysis. What they will do is, obviously, first they go to the website and they try to fetch the homepage. In the homepage, I will look for the brand-specific keywords, because I told you there are some websites that do not advertise the brands in their domain name. So here I just want to make sure they do sell the goods I'm looking for. If they have these brand-specific keywords in the body of the page, then I will go through a heavier stage, but probably the most important one, which is the feature extraction. I will try to collect as much information as possible that allows me to automatically identify the website. What we call features here, it's who is lookup. We also do geolocation of the IP. We look for everything that can identify the website. So all the email addresses we can find, either in the who is the record or in the body of the page, or we also follow the links to go to subpages. We also look for phone numbers in the body of the page, in the who is record, everywhere. We also look for analytics IDs, like Google Analytics. This is very useful, and it's because, you know, the counterfeiters, they're like you, they're businessmen, and they want to do business. And when you do business, you want to do marketing. And when you do marketing, you use Google Analytics. And the last one, which is a very powerful feature, is the banking ID, also called as a merchant ID. That would be, if the seller is using PayPal, for example, that would be his PayPal ID. So we gather all these features, we store them in the database linked to the original domain that is being investigated, and we call that the website ID card. Here are some screenshots of the features we extract. At the very top, you have a analytics ID. It's the add this button. On the left, you can see some phone numbers, some emails that we found in the body of a web page. At the bottom left, you see Google Analytics that is present in the HTML of the page. So we extract it, we store it as well. And on the right, you see a whois record where we extract automatically the name, phone number, email address, etc. I was talking about the banking ID. So for the banking ID, it's a little bit trickier. So what we do is that the crawlers detect automatically that there's a payment system, and it goes through the payment system. It puts in some fake data, some made-up data. So I do not personally know Natalie Portman, unfortunately, but we did buy her some very nice handbags. And we follow the process, and we stop at the very end, just before the payment. So we do not go through the payment. We do not send money and buy illegal goods. We stop right before, and sometimes you can see, depending on the platform they use, this banking ID that is very useful for identifying the guys later. Here, there would be Whitegates A316. So we have all these websites and all these features linked to the websites. What will we do with them? I told you at the beginning, the goal of the research is to optimize the takedown efforts. So what we will do is we will run some clustering algorithms to create groups of websites. Why would we do that? Because the old school way of targeting counterfeiters is to take down the websites one by one. It's very costly. Taking a website requires a legal action, it costs a lot of time and money, and it's very inefficient because counterfeiters, bad guys basically, are very well organized. They have thousands of websites waiting in line, and as soon as you take one of them down, they put another one back online within an hour. So it's a lost battle. So what we want to do is present not websites one by one, but we want to present groups of websites. But how do you define the group? What we want to do is group together the websites that belong to the same actor, to the same organization. So you can target directly a whole organization and not only just a website. And because we have a very valuable information given in the Farsight passive DNS stream, it's a traffic estimator of the number of visitors visiting the website, or actually doing the DNS query, but it's correlated to the number of visitors. And because they are marketplaces, it's directly correlated to the revenue they make. So you can target first the organizations that make the most revenue. So how would we group these websites together? How do we cluster them? The most natural approach would be to say, if two websites share common features, like we find the same email address, the same phone number in two counterfeiters' websites, they probably belong to the same guy. We have lots of websites, we have a lot of features. It looks like a machine learning problem. So naturally, we first tried some machine learning algorithms for clustering. We tried k-means, we tried hierarchical clustering, but we quickly faced tough problems. The first one was, how do you define a distance? How do you define a distance between two phone numbers, between two Google Analytics IDs? That's very tough. And secondly, we did not know in advance how many clusters we were expecting, and that's a big problem for k-means. So we looked for another representation of our data that would be more human-friendly and more machine-friendly, because we need to run algorithms on this data. This is how we came up with graphs. Graphs are a great way to represent our data because you do not need to vectorize it, so it's an easier job. And also, graphs come as a very natural representation of websites linked together as a network. And also, in the end, you get a very human-friendly representation of your data. To visualize and explore the graphs, we use this great open source tool, Gephi. You probably know it. You can handle up to millions of nodes and edges with it. And you can also add some colors to the nodes and edges, so you have a better visualization of your data, and it's very helpful. If you put your data in Gephi, at first you have this big black mess. But then you can add some color to the features. It gives it a little bit more value. And then you can run some clustering algorithms. We like to use Force Atlas 2, which is a network specialization algorithm. And it sets all the nodes and edges apart like this. And it groups the nodes that look alike together. In the end, you can clearly see some clusters. So that's how it looks like after running the algorithm. Now, we have the clustering algorithm. We have all the domains. The problem is an edge and a node are some abstract concepts. So how do we define a node and an edge? First, the naive approach was to say, okay, I want my data to be homogeneous. So I will say every node is just a website, plain and simple. And if two websites share a common feature together, for example, the same email address or the same phone number, I will just draw an edge between the two nodes. Say these two websites share more than one feature together, they also share some analytics IDs, I will just draw a thicker edge. So I have this concept of weighted edges. In the end, you get some nice graphs like this. You can clearly see the clusters thanks to the thickness of the edges. But there are some big problems. The problems are that it's difficult to see what is the relationship between two nodes, so between two websites. Do they share an email or a phone number or an analytics ID? You just have an edge. You don't exactly know, just by looking at it, what they share together. And the main problem was that the number of edges grow in the square number of nodes if they share more than one features together. So sometimes we ended up with billions of edges, which was too much for Gephi to handle. So we looked for another way to represent the data. We ended up with a heterogeneous way of representing the same data. But so it's less natural, but it's much more suited to this problem. Here, a node can be either a website or a feature. So here I see in pink the websites, and in the other colors I can see the features. Blue would be the banking IDs, green the emails, etc. I can see that site number, the website number 6 here. I found the email number 1 in the website number 6, but I also found the banking ID number 1. And I also found the banking ID number 1 in the website 10. So here you clearly see the relationship between the features and the websites. And that's the main advantage. The number of edges grow linearly in the number of nodes. That's much better for running the algorithms. So when I use this representation of data on the use case we will show later, you get that kind of a global overview where you can clearly see some clusters. So these clusters represent the organizations that run the thousands of websites selling illegal goods. And also, because I said we have a traffic estimator, we can target we know which clusters to target first. For example, here we have the traffic estimations for a couple of clusters. And we know which ones drive the most traffic, so probably the most revenue. So I give it to my legal department, and I say, you should take down the first cluster. Okay, now let's study a use case. We described all the methodology. Christmas is coming, so I'm thinking about buying a nice watch. And because I like nice looking watches, I will look for a Cartier watch. So what do? First, I subscribe to Farsight's passive DNS data feed. I receive JSON data like this, all the DNS lookups. And I first look for the brand-specific keywords. Here, that would be Cartier. Then I look for generic keywords, for example, watches. And after a couple of days, I set aside already 50,000 pretty good candidates of websites selling counterfeited versions of Cartier watches. On all of these 50,000 websites, I start the crawlers. And for example, let's take this one, this nice little guy called perfectwatches.cn. By the way, you can see that the counterfeiters do a pretty good job at replicating legit looking websites, so that pretty much any customer can be lured into thinking it's legit. So let's study this guy. My crawler will go and investigate it. They will look for first the brand specific keywords in the body of the page. Oh, there's a match for Cartier, so I know this website does sell Cartier watches. Pretty good candidate. So I start the feature extraction. I don't know if you saw earlier, but at the top you have a phone number. So here my crawler sees it, automatically fetches the phone number, stores it next to the website, and I also find the analytics ID. Here you can see that the analytics ID ends with B39C. We will see about it later. So I complete all the feature extraction. And then I put all the data in Gephi, run the clustering, and I end up with a global overview like this with 50,000 nodes. And the guy I was just showing earlier is just lost here somewhere. You can already see some clusters actually. But if I zoom in a little bit towards my guy, I find a connected component. So it's let's say an independent subgraph. And it's clearly a single organization. It's one organization administrating dozens of counterfeiting websites. You can clearly see the organization here. The pink dots are the websites. The other ones are the features. And so if I zoom in a little bit more, we find our guy here. And you see that if I was to take down perfectwatches.cn, the next day, the counterfeiter would put online watchesinc.cn, for example. So it would be useless. So what I want to do is target the center. Here you see clearly that there's a centerpiece in this graph, the red dot. And what is the red dot? It's the analytics ID ending with B39C that we saw earlier. It's because the guy administrating the dozens of websites is using the same analytics ID for all his websites. So what I would tell to my legal department would be, do not try to take down perfectwatches.cn. Try to look for the guy behind the analytics ID and take him down. Okay, so that was the use case on luxury watches. We also try to apply the same methodology to different kinds of businesses. Here it's for narcotics. So I will not go through the whole process. You got it now. But cannabis was a very interesting domain because it's trickier because depending on where you live, selling cannabis can be legal or illegal. So it's much more trickier to distinguish the false positives and the true positives. In the end, you still get some clusters, and this is why the clustering is also efficient, because all the legit websites will be gathered into clusters. So you can also remove much faster all the false positives and concentrate on the illegal websites. And because I have this traffic estimator, I also know which websites probably sell the more marijuana on the web. So, about the takeaways of this presentation. The first one, you probably already know it, that counterfeiting is a significant and growing online threat. that the current solutions that are based on zone file analysis and websites takedown one by one is inefficient. And here we showed the research to use passive DNS data to really optimize your takedown efforts by using some network science and feature extraction applied to this kind of data. You can also use similar this research for different for other problems. And we have also quite recently partnered up with Farsight on another topic, but a similar problem. We studied the upcoming US election, and we also studied the passive DNS data stream, looking for domain names that were related to Donald Trump and Hillary Clinton. And we did some lexical analysis and put all that in very neat looking visualizations. You can check it out on our blogs if you're interested.
Thank you. We have a free DNSDB test drive for anyone who wants to go to that case-sensitive URL. You're welcome to sign up for the Farsight DNSDB and plow through 6 years of history to look up what you'd like to look up. It's good for 15 days. This technique also works well against the darknet markets, because darknet markets are still run by the same criminal organizations who run the clearnet markets, and you're able to start picking out identities and IDs that go between each other. And for those of you who've caught the news, the Dutch police just released a .onion site that starts tagging all these usernames they've seen across the darknet markets, tying them together and tying them to people. Any questions? We lost our timekeeper, so we can go all night. No one has any questions? Or no one wants to say anything? Sure.
Yes, are you actively working with law enforcement, or is it just business?
Are we actively working with law enforcement?
Not directly, actually. We work with the corporates, and they send it to their legal, and their legal work with law enforcement. The difficulty here is that the websites can be in different countries. So it works very well with multinationals because they have offices in pretty much every country. Yes, if you want to know a little bit more about the story, the timeline, we had the idea about a year ago when we attended Paul Vixie's talk at Black Hat USA, explaining all the amazing stuff you can do with passive DNS. And then a customer of ours in the luxury industry came to us asking if we had any solution for addressing the counterfeiting problem. And we remembered Paul Vixie's talk, and we thought about passive DNS. This is how the research started, and it started in cooperation with this major luxury brand. So at the very beginning, it was designed for corporates and not for law enforcement. So yes, we developed that research in cooperation with the corporate guy, and in the end, it became a product.
To be clear, Farsight does work with law enforcement, and they heavily use our database to look up past activity, to look up who owned an IP or who hosted what on an IP over time. Any other questions?
Yes.
Do we have a lot of false positives? It depends how good your regular expressions are to look for things. If you're looking for something that's really common, like mail, you'll have billions of domains quickly. If you have something super unique, like Fluffy Bunny, you're likely to have less false positives. And a lot of what this network science technique lets you do is start looking through to filter out, like we did with the cannabis, to filter out, these look legitimate, these are not. This question over here. If I heard correctly, is there a customer for the?
How did you get the idea of looking for websites? Is there a customer who wants to do that?
Do you technology there? These are customer websites. Yeah.
No, I was explaining that at first it started with a major luxury brand, and then we had the idea to apply it to illegal drugs. First it was Cialis and Viagra, and then we thought about marijuana explicitly because it's a trickier business for what I explained. That in some places it's legal, some places it's illegal. But for the narcotics, at first we targeted the pills. Yes. Does it work for phishing websites?
Yeah, so if you have like a visual analytics side,
Yeah. You want to take that one?
Sure. Network science, I guess the larger answer is yes, it should. We haven't actually done it, but for phishing websites, you have the same criminal organizations behind them. You should be able to find the commonalities across them, even though the criminals may be well coordinated in how they do it. They will still start using common elements that we'll pick out. Network science as a whole is what we're using here. It's been used for looking at the epidemiology of diseases, as the spread of diseases, the spread of memes through social networks. Back in the 1930s, there was a psychologist who mapped out social arrangements of kindergarten, primary school, kids just entering school, and it all works the same sort of way. Find the common elements and look through the graph theory and the inference and all that. So it should work fine against phishing sites.
Actually, we did try against phishing websites. You need to tweak a little bit the feature extraction because you are not looking for exactly the same features. And we were not ready on time for this presentation, but we know it does work. And we are actively working on that, and we should release a product next year dedicated to the phishing threat. Another question?
No other question? Okay.
Thank you.
Thank
you
you.
very much.